online. So first of all, thank you very much. We will try to be very concrete in this part of the webinar. Is the first webinar of our THERMOS tool. So the agenda for today, we are a little late, but we will go directly to the energy system mapping and modeling process within THERMOS. We will hope we will have some minutes for questions from you. But just some quick introduction about THERMOS. Probably you will not be familiarized with the project. All the information is in our web. I think that through the registration project process of our Train the Trainers workshop, you have been able to understand what is the scope of THERMOS. We are a EU Horizon 2020 funded project, and our aim is to provide an advanced energy system data and models in a user-friendly open source software. You are going to learn today a first approach of how THERMOS is functional for all of your needs. THERMOS is aimed to optimize local district energy network planning processes, to support sustainable energy master planning on a local, regional level, and also to identify and select low carbon heating options in real geographies. And that is one of the most important features of THERMOS. You might have several questions about the program itself because you have received several information, but just to clarify the three components or four components of the webinar itself. First of all, we are going to have three instructor-led webinars starting from today, a little late, but we have make it happen. We are going to have our second and third webinar in October, the next one on October the 8th, and the other one in October the 22nd. We will have 1 or 1.5 hours per webinar of dedication on your side, and we count on your time for this. You will be also able to listen the recorded webinars. They will be recorded. In fact, this webinar is being recorded now in order to you can access it at any other time. We'll also be encouraged to listen to another webinars, recorded webinars. We're going to send the information for you. There are some materials especially prepared for you to understand district energy planning beyond THERMOS. You will also be invited to review several documents that we have prepared. We have the THERMOS Innovation Catalog, the THERMOS User Manual, and some publications that our partners have developed. At the end of the program, you will also be called to develop a case study with THERMOS as the key component of this. There will be two options. You are going to define which option you would like to develop. You will be able to have a THERMOS tool guided exercise, but you can also be able to have a THERMOS tool case study development based on the realities of your geography, your city, your industry, your company, specifically for you. Some news about the programs. Well, this is just some news we are going to share it with you, but now we would like to go specifically to the webinar itself. So now I am going to give the pass to our presenters, Martin Holly and Tom Hinton, that they are going to present the tool for us. So please now 1 minute until we configure Martin and Tom participation and presentation. Thank you very much. Please, all the questions you may have, we encourage you to put it in the chat, and we will be able to answer it at the end of the presentation. Thank you. Martin?
Hello. Can everybody hear me? Can you hear me, Daniela?
Yes, Martin, we can hear.
Good. Okay, great. So
thank you.
We've got communications at last. Thanks for everyone for hanging on, those that are still with us. And thanks Daniela for the introduction. So yeah, I'm Martin Holly from CSC, And yeah, in the time that we've got left, we're just going to go through what we were intending to go through, just a little bit quicker, I guess. First of all, I'm just going to run through just a handful of slides to introduce you to the THERMOS tool itself, and then I'll hand over to my colleague Tom Hinton, who will give you a quick brief talk through the THERMOS tool itself. So what is THERMOS? Thermal Energy Resource Modeling and Optimization System. That's what it stands for. As Daniela was saying, it's an open source tool, web-based, and it's for planning district energy systems. And the key thing is that during the THERMOS project, we've been developing it in conjunction with target end users, so partners across 8 countries, and that's quite a few local authorities as well. So we're trying to make it as fit for purpose as possible by actually working with the people who will end up using it. And it aims to set a state-of-the-art standard for district energy system planning, because we know there's a lot of inconsistency out there at the moment with regard to planning district heating systems. So we're trying to make it more standard and make it the go-to planning system. So what's it used for? It's really for the initial stages of network planning, energy system planning. You can see there the different stages of a typical heat network project, starting with master planning, heat mapping, that kind of thing, and then you have some pre-feasibility or techno-feasibility stages, and then a little bit of detailed project development as well. So THERMOS can be useful for those processes right from the start, certainly for initial heat mapping and master planning, and then you can use it as you wish as you go through into more detail in a particular project. It's still useful right up to that detailed project development phase. Of course, you need to be putting in your own numbers for costs and things like that at that point. But yeah, it does give you a good head start on that. It's used for 4 main use cases. One is just expanding existing district heating systems. Also, where you have a known energy source, you can use it to then start trying to identify local energy demands. Also, where you have known demands and energy sources, you can then look at what kind of networks might join the two up and how to optimize those. And also, it's a relatively new feature on it. It will also look at non-network solutions. So it will start to look at insulation options for energy demand options for buildings, and then see whether the best energy supply option is either via a network or through an individual system such as a heat pump. Who can use it? So anyone really. It's open source, as we say. It's mainly designed with local authorities in mind, so local authority officers who are involved in planning of district energy networks, but other stakeholders can use it as well. There's no specialist knowledge needed, really, to get up and running. There's a basic level of use most people can use it in that sense. There's some extensive training resources available along it with an online manual and a quick start guide, and it's got quite an intuitive user interface. So it's quite easy to get up and running with it once you've had a little read of the quick start guide, or indeed participate in one of these webinars to see, just to have a little guide through it to see what it entails. There is some experience of GIS systems needed, and knowing your way around local data sets if you want to upload your own local data. But yeah, some people I know do use it without needing to do that. So yeah, that's just an option really, but it is useful if you want to use your own local data. So what do you need to start? Just a standard web browser. It works using a remote server, so there's nothing to actually download on your computer, and all the more powerful computing elements are done elsewhere. So that there's no constraints on the system you use for that. You need to you need to look at an area that you're using and make sure it's covered by OpenStreetMap data, and that is most areas, although it is patchy in places. But as long as you've got that in there, showing buildings that you want to analyze, then that's you can start. That's the way. And then, yeah, you just need to set a problem to be solved. As I was talking about uploading local data, yeah, there's if you can do that, and then we're talking about things like building height data, typically LiDAR data, which describes building heights. That's useful to have alongside it to give better energy demand estimations for the building. Building polygons, especially if they're not covered by OpenStreetMap, and things like energy benchmarks or actual demands of buildings that you might have locally obtained that you can then input and replace the estimates that the tool provides, and also some local cost data regarding energy supplies, pipe installation, that kind of thing, heat price. Just a quick recap of why to use Thermos and what its strengths are. As I was saying, it's developed with a range of local authorities, and it's undergoing validation within the industry. We've been testing the energy demand model on, it's like a predictive model which has been trained on 30,000 buildings in Copenhagen, and that's coming up with encouraging results. It's browser-based application. It's quite fast, easy mapping. The whole process is quite straightforward and rapid. And the actual optimization function, it depends on the size of the problem, but that's usually quite fast as well. What that enables you to do is then you can do repeat analysis where you tweak certain parameters to do sensitivity analysis. And that in turn then, saves a lot of time and effort, and also money where you may be asking other people to do that, external people who you might have to pay. So you can do that yourself. And hopefully the use of it, once it's disseminated and in use, it will encourage well-designed networks in the right locations, which will then encourage the right amount of emission savings. So that's a very quick introduction to the tool. I'll now hand over to my colleague Tom Hinton, who's also works here at CSE, the Centre for Sustainable Energy. We're in Bristol, in England. And Tom is just going to give you a quick guide through the tool online.
Hi. I'll just have to spend a moment working out how to use Martin's computer, because this is unfamiliar to me. I was just trying to use this mouse, but it doesn't appear to go. No. It's big. Thanks, Martin. Just trying to get the mouse to work. Anyhow, yes, as Martin said, Thermos is delivered as a web application, or that's certainly the easiest way to use the model. And it is something you can have a look at yourself if you like. You can do that now or after the presentation at your leisure by the URL which Martin gave on the slides. So the system has a little bit of access control. The purpose of this is mainly just so that you can use your own data in an environment where you're confident other people can't see it. But all you need to do to sign up for an account, if you do want to use it, is fill in these two boxes and click this button. Anyway, I've done that before, so I can click login, and that should work. There we go. So work in THERMOS is kind of organized into projects, and a project is a sort of unit of collaboration. So you as a user on the system can be participating in many projects. Here are a bunch of ones that are related to my account, and within each project you can have several users. So I'm going to have a look at this project here, which I called Webinar, which is something I made in order to give this brief demonstration. So this is sort of, I don't know, the contents of this project, and the sort of context within which you ask THERMOS a question. So, like Martin said, it's a tool for answering questions, really, about heat network planning. So the context within which you have to design a question is called a map, and you know, that's what you might imagine a map is. It's a description of a place, and the description consists of the features relevant for planning a heat network. So that's where is the demand for heat, where are the places we might install heat pipes, that sort of thing. So I've already created this map, and later if there's time, I'll show you how easy it is to make a map, but I thought it would be better to start at the end and jump straight in. So I'm going to click this button, New Network, which is essentially saying I wish to design a heat network within this place. So what should we call this? So I'll give it a name there. So far, I guess this is all sort of not that different to things you might have seen before, kind of web-based mapping systems or GIS systems. There's a map of a place. In this case, this is a place in the UK called Huddersfield, which I chose essentially at random for this. And if I tick this box on top of the kind of satellite imagery, we get a heat map. So, you know, the red bits are where there's more demand for heat, and these blue bits are where there's less demand for heat.
Tom,
yes?
This is Daniela. Just one thing,
Hi.
our participants, some of them mentioned that probably you can go slowly in presenting because the moving of the screen versus your voice is a little late. So could you please just go slowly while you show the screen?
Okay, sure.
Yeah, thanks.
Let me know if I speed up, which could happen.
Yeah. No, it's okay. Thanks.
Sure. Okay. So yes, in case you missed that, I guess, yeah, all I've done so far is go into the application and tick this box to turn on a heat density picture. Now, this is sort of, I guess, the kind of thing that you may have seen before in the context of heat network planning, a sort of density estimate, but that's really not what THERMOS is about. The density estimate is displayed mainly as a kind of illustration of where there is heat demand. But what THERMOS is really interested in, so I'm just zooming in a bit, is in the real sort of the detail, I suppose, which is expressed in terms of where specifically there is demand for heat and where it's possible to install heat pipes, and what the best way is to connect up some demands with some heat supply following those heat pipes. So I'm going to turn off the heat map because personally I find it distracting and difficult to look at, and I'm also going to turn off the satellite imagery because I don't think it's very sort of, it's useful for figuring out where you are, but once you know where you are, it's sort of busy to look at. So, I don't know, let's go down here, look at this bit. So you can see that there's kind of two types of thing on the map at the moment. There's these things like this, so polygons. Those are buildings. And then there's these lines, which are paths or roads. And these two things are the two sort of basic elements that THERMOS understands and can use to compose a heat network. So, yeah, I guess the next important thing that you need to know if you're trying to design a heat network is to have some idea of the demand for heat in particular locations, in particular buildings. And as Martin alluded to, that's something which THERMOS has an opinion about. Although if you have better evidence, you can supply your own figures. So by clicking on this one building here, you can see in this sort of region on the right-hand side of the screen some information about that building. This is what THERMOS believes about that building. So you know it's an industrial building. We'll skip over this stuff for now. And it has some demand for heat. That's this number, 224 megawatt hours a year, and it has some peak demand requirements as well. So 133 kilowatt connection required, or would be required, delivering 224 megawatt hours a year. And if I, click around on some different buildings, you'll see these slightly different numbers. And I guess, as you might hope, smaller buildings have smaller numbers. That's kind of reasonably realistic. So these estimates are produced using a sort of fairly complicated form of regression, which uses some data which is taken from Copenhagen, but then sort of essentially predicts based off that data and information about the shape of the building and information about the place where the building is, predicts a demand and similarly a peak demand. So far so good. I guess you can see that this is kind of like a little sort of tiny GIS almost that you could use to click around some buildings and see what the demand for heat was. And if you want, you can select a bunch of buildings at once. Let's do that. I'm going to draw a box like so. Stay there, and you can see some information about a bunch of buildings. So here I've selected 201 things. 48 of them are buildings. 153 of them. The rest of them are bits of path. And there's various different types of each thing. There's a bit of information about where they are, and you can see, this set of buildings would require 8 gigawatt hours a year, and a total peak of 5.3 megawatts, and there's 5 kilometers of road in that box. So, I guess you could use that to do a sort of a really trivial kind of linear heat density analysis. But what I guess you really want to be able to do, and this is sort of where the idea for THERMOS kind of came from, is to say, okay, well, given all of these demands and these little bits of road, where should I put a heat network? Which of these paths is the right set of paths to use if you do want to build a heat network, and would it make sense economically to do so anyway? I might just expand the box I've drawn a little bit to cover this top. Oops, I used the wrong button, wrong keyboard for me. I'll select a slightly bigger box. So yeah, the purpose of the application, I suppose, is to automatically answer questions of the sort that I described. So the way this is expressed to the computer is as Martin sort of alluded to, as an optimization problem, and optimization is generally about making decisions about a bunch of questions that you have in such a way as to produce a result that is in some sense a good result. And the questions that THERMOS answers are all of the form: should I connect this building to my heat network? And should I put a pipe down this piece of road? And how big should that pipe be? So to sort of phrase the question to the computer, we need to tell it which things we're considering. And that, in optimization terms, is this constraint field here. So you can see at the moment it says 322 things, and they're all forbidden. What that means is they're not being considered for inclusion in a heat network, but we can change that. So if I right-click with the mouse here, a little menu comes up for the things I have selected, and I'm going to say set inclusion optional for all these roads. That's turned them all blue, which is just a color coding to show you that those are now things that would be considered. The buildings, however, are still forbidden. They're all white. So I need to make those open to consideration as well. So I'll do the same thing. So now this whole patch that I had previously selected has gone blue. And the blue bit is essentially the bit where we have a question. So to sort of allow us to focus on that, I'm going to click this button here, which will essentially remove from the screen all of the things which we know we're not thinking about because we've focused on this bit here. So I'll click this button. So now this is our sort of target area, I suppose, that we're thinking about. And you can see in here, there's a bunch of different ways you could run a heat main if you wanted to get from one place to another. Quite a lot of different buildings that you could choose to connect or not connect. So there's, even in this sort of small patch, there's a reasonably large question open to you of how would you put a heat network in here. Before we can answer that question, though, we do need to specify one more parameter, which is where we're thinking about building our energy center. Where do we want to put in a heat plant? So let's say here, I don't know what this building is, but for the sake of our demonstration, we'll say this is where we're going to put our plant. So I'm going to right-click on that and go here to convert it into a supply point, a building where we can build a plant. So we'll say we could build up to 10 megawatts, let's say. Let's say it's going to cost us 2,000 money units. Actually, that's already in thousands, I think. So that would be 2 million. I don't know, I'll put 20 in there. And I don't know, just skipping over the other numbers, they essentially affect the cost of building it. We can come back over those later. I'm going to put in a number for the price of heat. That's essentially the kind of one of the key determining factors for the economics of the network. So this is 3 cents or pennies per kilowatt hour of heat supplied, which is reasonably cheap, I suppose. So, and that's the cost to the network of producing the heat at the supply. So that the cost of injecting 1 kilowatt hour of heat into the network is 3 pence or 3 cents. So So I turned that into a supply, and this has gone stripy as a result. That's just the coding to show that something is a supply location. And I don't know, let's do one other thing. Let's say that we definitely want to connect this building here, Wood Auto, to the network. This is just to illustrate one of the other types of constraint, or the other type of constraint. So if I say that this particular building is required rather than optional, it turns red, which shows it's required. And I think that done, we've probably specified, at least on the map, all of the things that we need to specify to be able to ask the question, well, what heat network should we build given these parameters? So we can press save and press go, and it will go away and think, hopefully not for all that long, and produce an answer. While this is running, perhaps I should walk you through some of the other bits of the application interface, so that you have answers to some of the other questions which probably come into your mind looking at that. So we can just go and look at it in another browser tab. You can see there that thing spinning around shows that that's still running. So yeah, there are a bunch of other kind of controlling parameters for the network model that I didn't really go into in that sort of quick illustration, which are all accessible by, sorry, that was a bit quick, but if you click on this symbol, the project logo in the top left, this thing pops up. And this will allow you to look at some of the other parameters which control the behavior of the system. So, for example, tariffs, which control the revenue received by connecting a particular customer to the system. So this is sort of the other side of the economics of it, I suppose. A minute ago, I showed you the supply costs, so the cost of putting heat into the system. This page is where you control particular buildings, the revenue received for supplying heat to buildings, and also the costs associated with connecting the buildings. There's a bunch of other parameters controlling the cost of the pipes that are going to be put in, and you can adjust the cost of pipes based on based on whatever you like, but the typical cause of different costs would be the different type of surface that you're having to dig up to put the pipe in. And these costs vary to reflect the pipe size that is required in order to carry the heat to the demand. And as Martin alluded to, there is also some simple modeling of some other technologies to do a kind of whole system optimization, which I don't think we enabled it to look at those before, but you can create definitions of insulation in this page, so demand reduction technologies essentially, and you can also model alternative heating systems that are sort of individual systems rather than network systems to install within a building. However, those are only really considered if you attempt to do a kind of whole system optimization instead of a network kind of financial model just for the network. So let's see, has that finished? Yes, it has. Good. So while I was waffling, the computer was thinking, insofar as computers can think, and producing an answer to question that we posed it, which was what network should we build? And you can see on the map that stuff's changed colour because we've got a solution back. So there are a few different colours here which mean a few different things. I'll just quickly say what they are. There's this sort of garish magenta colour. These are buildings or pieces of road that, although I included them, are not feasible to connect to the network simply because there's no way to get to them. So this building here, you can see, which is a school, has no connecting line included, so there's no way to connect that to the network. It's not physically possible. Similarly, this piece of line doesn't go anywhere, so that's also been excluded, and same with this piece of line. Then there's bits which have turned yellow. These are bits that we could have used, but as it says here, where it says in solution, no, we've decided not to use them because they didn't make sense. They were not economical. So given the price parameters that I put in, this building here was considered uneconomical to connect, and you can kind of see why. I mean, you know, it's the only thing down this way. You wouldn't want to go there. It'd be too expensive. And, you know, there's a few other bits of pipe that have been left off, like this bit here, because, well, you'd only come down here to reach this building, and we got there this way instead. And then finally, there's things which are blue or red, as before, and those things are things that have been included in the network. So now that it has been solved, this box on the right displays a bit more information. It will tell you about the what the optimization has selected to go there. So in this case, we've built a plant here. Its size is 4.3 megawatts. It receives £7,000 a year, and actually that's probably it, just from supplying its own heat, I think. And this number here, coincidence, 63%. That's essentially telling us to what extent the size of plant there is less than the combined peaks of all of these demands as a result of the fact that their peaks don't always occur at the same time. This is also called load diversity. And the same information is present on, for example, bits of pipe in the network. So, I don't know, this pipe has a coincidence number of 100%, probably because it only goes to this building. And, you know, you can see here, let's say, the capacity for this pipe is 72 kilowatts. That's a fairly small pipe. It's a 13 millimeter pipe. The reason it's 72 kilowatts is because the peak demand on this building is 72 kilowatts, so fair enough. And, you know, you can also see 400 kilowatt hours a year of heat losses out of this pipe, which is 4 watts per meter, which is a reasonable number. And, you know, you can see that we spent, just for this little bit here that I've got selected, 3,000 or 3.3 thousand money units, 7,000 for those 2 bits. So, yeah, hopefully this illustrates on the map the kind of decisions that the model is making. So, you know, some buildings have been connected, some routes have been chosen, and then some other buildings have been left out because they're not worth it, and a few bits are just not usable. And there's a sort of a more detailed, you know, breakdown of the costs and benefits of the different bits of the system available in this other page here, the solution summary page under the solution section. So this shows you, you know, here are all the different sizes of pipe we considered, and here's how much of each one we used and what they all cost. And here are all the demands that we connected up, and again, how much we got paid for those demands. Here's the supply that we built and how much it costs, and some other sort of details which are all not relevant here because I didn't ask the model to think about those. So yeah, that's probably a reasonable summary of what this bit of the system does. How are we for time? How long have I got? It's 4:05.
Daniela, how long should we draw to a close now with some questions?
Yes, Martin and Tom, thank you very much for your wonderful presentation. So yes, we have a lot of questions from our participants. We have around 70 participants in our webinar, which is a total success. But we have a lot of questions, so we can start on that if you agree.
That's fine by me, yeah.
Okay, so the first question we have are from, just 1 minute, please. We have one question from Jorge Lopez Jimenez. He asked if when someone is introducing energy data to the tool, how this data is going to be managed and how, if it's going to do any calibration or improvement of the THERMOS tool, if some data is included by the user. Energy data specifically.
So, yeah, as far as using your own data is concerned, that's certainly something which the tool, it's designed around the idea that you may well want to do that. So, yeah, there's kind of an easy path where you essentially don't. I'll just quickly show on the screen. I don't know whether the screen's still visible, but oops, wrong button.
Yes, it is visible.
It is visible. Okay. So there's kind of there's when you're setting up a map, which I didn't go through, you have two choices, and one choice is to take map data from OpenStreetMap, which is a kind of sort of open source kind of public map of the world, or you can put your own data in if you have some GIS data and use that to construct a map. As far as how the data is managed, if you do put in your own data, you can see it, and other people who you invite to your project are able to see it. We don't use the data to improve the model's estimates or anything like that. We won't look at any data that anyone puts into the system because I suppose that would often be difficult for people from a kind of licensing perspective. We don't really know whether, quite often people want to keep things secret or whatever. So we're not really looking to gather other people's data and make use of it in that way. Does that answer the question?
Yes, I think so. Tom. I think that when our participants will be able to explore the tool in detail, they will be able to understand what are the capacities of the tool to process the different types of data. Thank you very much. In that same in this issue of the data and how the model of THERMOS was built, we have several questions that I would also to mention to you. So the first one is related to the data, how accurate is the modeling, and how has the data and the modeling been validated. We also have another question from Aristides Savros that says that if the values of the demand and peak energy are automatically calculated, or do they have to be inserted by the user? Those two questions probably are on the same context. Can you give an overview of this, please?
Yes, absolutely. So I guess I will answer the second question first. So the peak demand and the annual demand figures In this example that I did, they've been predicted using a model, and I will speak a little bit about the model in a second because that's sort of relevant to the first question. However, the application does not require that you use these modeled figures. You can change them directly in here if you want. So I pressed a button which would let me change. You know, I can say for this building, actually, I think these numbers are different. So, you know, if I do that, I've changed it. And when you create the map as well, obviously that would be a laborious process to go through and change many buildings in that way. So if you do have existing, you know, say you have metered data for a set of buildings or a set of estimates that you particularly like, then when you create a map in the tool, you can tell it to ignore its internal model for heat demand and just use some figures that you like, or use a set of benchmarks that you like. So that's the second question, which is where do the estimates come from? So in summary, the answer to that was either the application makes them up or it uses what you've told it. As far as the first half of the question is concerned, the accuracy of these figures and what validation has been done. This is a difficult question to give a really good answer to, because there's not all that much high quality data to use for validating the outputs of the model. However, so there is good data from Denmark, because the Danish have an enlightened approach to the provision of public data. I believe that we have done fairly extensive cross-validation of the model results in Denmark, where it appears to work well. And I think we have also done some sort of validation in the UK against what in the UK are called the small area statistics, which are a sort of aggregate figure for fuel consumption in kind of reasonably big geographical areas, and it appears to work quite well. And we are currently engaging with some different industrial partners, some what's the word, consultancies that do a lot of, you know, heat network pre-feasibility studies to sort of get them to kind of sense check it as well. So I think that's sort of where we are. I believe that there are, I don't know whether it's in press or whether it's been submitted for publication or what exactly, but I also believe that there's some academic work which probably speaks about this in a bit more detail, but I cannot, off the top of my head, remember exactly what the situation is with that, so we can probably get back to you. Does that explain or answer those questions?
Yes, Tom, it does. Thanks. In that same context, we have several other questions. I will try to summarize them as a matter of time. We have some questions regarding that if the power estimates automatically adapt depending on the city location.
So you need to tell the model essentially one number, which is a summary statistic about the weather in your location, which it will use to calibrate the estimates that it produces. So that's the number of heating degree days in the year relative to a 17-degree sort of threshold temperature. There's some details about this in the manual, in fact, in the help, which you can get to by going like this, and probably somewhere in here there'll be some explanations about that.
Okay, Tom.
Next question.
Yes, is it possible to verify? This is more questions related to the data input that would be made by the different users. So it says that if it is possible to verify some technical KPIs of the optimized network, for example, pressures, flows, after the model is run.
So you could, so for reasons of kind of making the optimization tractable, the model doesn't go down to sort of modeling the hydraulics. It uses a bunch of fits to kind of suggested sort of velocity curves. But anyway, that's getting into the weeds a bit. If you wanted to sort of verify something like that yourself by hand, you could certainly download the GIS data for the network, and then you could probably stick that into another tool that does a more detailed set of calculations, including the sort of the hydraulics, and work that out for yourself. But the model itself does not do that.
In that same context, Tom, we have another question says that if it is possible to upload piping shape files, like for example in multi-line and string format or point format. This is a very technical question.
So you can, when you are producing a map, you can put in GIS data for the buildings and for the this stuff, the line segments. So you could certainly, if you have an existing drawing of a network, you could put that in as effectively as the road network or the places where paths can go, and run the model using that existing network. So yeah, that's something you could do, or you could laboriously draw them in by hand by clicking this button here and sort of going like this, but you probably wouldn't want to do that, except for one or two, if you just got a few missing bits that you wanted to put in like that or something. So I guess the answer is yes.
Okay, Tom, another question, if after the modeling, is it possible to export the network to a SHP file? To insert it in QGIS, for instance?
So you can save it out as, let me go and see here. So in this page, there's this button which has no descriptive text, which looks like an arrow pointing downwards. If you click on that, you get a GeoJSON file, which is analogous. So you could open this. I don't know if Martin has. Do you have QGIS on your computer?
No, I don't. Not on that.
So I don't have QGIS on here, but I can probably go and look at that online, actually. So it's just another GIS format. So I've just saved this webinar network, and then if I were to go and find it here, so yes, you can get out the stuff as a GIS file, and you can see in here, all of the various sort of properties that have been computed do get put in there. So yes, you can get stuff out. Hello?
Yes, Tom, we can hear you.
Oh, okay. Well, that was it. Yes, you can get you can certainly download the results as GIS and then process them externally using, for example, QGIS. Yeah.
Okay, we have. I will have only 2 more questions taken. We have several questions posed by the participants. We will process these offline, a lot of them, but there is questions related that if there is not enough data on the consumption, if it's possible that the tool gives not network as an optimization run.
I'm not sure that I understand the question exactly.
Could you repeat that?
Yeah.
Yes. That when there is not enough energy demand or consumption in the city or the location, is this possible that the tool gives no network as an optimization result?
Yeah. Yeah. So there are 2 modes in which you can run the optimization. There's one in which the objective is to maximize the NPV of the network that it attempts to build. And there's another one in which it attempts to maximize the NPV for the whole system. So including the cost of heating buildings not connected to the network. So those sort of reflect 2 different perspectives that you might be taking, one as a sort of company considering building a network, and the other as a, like a government body or something interested in the broader question of how to supply heat. But certainly if it is not economical to connect a particular building, then the model will decide not to connect that building. And in fact, in the small example that I did, I believe there was a building in which, yes, this guy was not connected, and that will have been because the demand, so in this case, that will be because the revenue to the network was not offset, did not cover the cost of the pipes. In a different mode, if I had set up a bit more stuff in the settings, you could get the application to choose on a kind of whole system NPV, so not considering the network economics alone, but considering the total cost of heating all the buildings. You could also get it to pick between, let's say, I don't know, a gas boiler and a heat pump and a network connection for that building. So it can make decisions of that sort, yes.
Thank you. Thank you very much, Tom. The 2 last questions. I apologize to all our participants that we will not be able to answer all the questions in this webinar. We started a little late, but now we will be able to answer as much as possible. 2 more questions. We have a question regarding that: is the optimization implemented as a deterministic optimization or as a heuristic method?
The optimization is it is deterministic in the sense that it should always produce the same result, although there may be some, I'm not sure, there's a sort of technical detail there. So anyway,
Yes.
I guess what I would say, it isn't a stochastic optimization in the sense that it is not optimizing an uncertain result. So, usually when you think about stochastic methods, they are for reasoning with uncertainty. We don't have any uncertainty in this, so there's no, you don't put a distribution on the demand for a building, there's just a figure. So in that sense, it is a deterministic optimization. The question about heuristics, I mean, the whole thing is heuristic. There are, in the sense that there are parts of it which are an approximation. So a sort of, that's a bit difficult to answer precisely, I suppose. But
what we are going to do, Tom, thank you for this, and also to Mr. Christopher Hawk that did this question. I'm going to put you in contact with him, so you can probably have a separate call or
Okay.
chat in order to clarify this, please. As a matter of time, as I said before, we need to close the webinar. We have a super suggestion for Mr. Felix Ritz. He asked if we should collect all the questions and prepare the different answers, and we will share it with all the trainers. I think that is a very an excellent idea, so we will do that, okay? So thank you very much.
Sense.
Yes, we will take all the questions that we have had in this webinar, and we will share it with all the trainers. So thank you very much for your time. Before you leave, I just want to share the final a final slide. I would like to thank again to Martin and Tom for this, and just some minor announcement and news of the program for the next edition. So please, to all our trainers, please, you will receive an email with this webinar recorded, and you will also be invited to watch another webinar on thermal energy supply and demand in Europe that will give you an extra concept of district energy planning on a local level. You will also receive the link to explore the THERMOS tool. We will also share with you the innovation catalog. That is a new document that has been published. Please note that the upcoming webinar will be in 2 weeks, October the 8th. Please, this time we will guarantee that the tool will not fail, that we will be able to connect on time. And please note that we are going to introduce the final exercise of the Train the Trainers program in this date. For the ones that are familiar with other district energy tools and projects, we are going to have our THERMOS Inspire event within the Celsius Summit in Brussels on October 18. We had some questions regarding other tools, part of the Horizon 2020 call that we are part of together with THERMOS. So you will have here information about this. If you can attend, you are invited to participate. And also please note that we aim to have a Train the Trainer workshop in Berlin on December that you are all invited to come. So these are the news of our Train the Trainer program. Thank you very much for your time, participations, and patience. And we look forward to see you in 2 more weeks. Thank you very much. And if you have any doubt, please count on us, Alexandra Fall, myself, and the CSD team in order to answer any of your questions. Thank you very much. Thank you, Tom and Martin, too.